is f of x continuous and or differentiable at x equals 1? Well, the first thing to test out for is continuity, and in order to do that, we need to determine the limit of f of x as x approaches 1 from the left, and the limit of f of x as x approaches 1 from the right. Let's start off with the left. As x approaches 1 from the left, we can directly substitute 1 into our polynomial, and we'll get 5 minus 4 minus 1, which is equal to 0. And then we can do something similar as we're approaching 1 from the right on f of x. We can use direct substitution, and we'll have the natural log of 1, which is also 0. Notice both of these values are equivalent. Therefore, f of x is continuous. Therefore, we can rule out answer choices A and C, which say that f of x is not continuous in both cases. So now we have to determine whether or not it's differentiable at x equals 1. And to determine that, we need to find the slope of the tangent lines at this x value of 1 in both pieces. That's also equivalent to finding the limit of f prime of x as x approaches 1 from both the left and the right. So first let's figure out what f prime of x is for our two pieces. So we would have 15x squared minus 8x for x values less than or equal to 1. And then the derivative of natural log of x is 1 over x, and that'll be for x values greater than 1. And as I said, we have to determine if the slope of the tangent lines, or f prime of 1, is the same for both of these, or the limit of f prime of x as x approaches 1 from the left is equal to or not equal to the limit of f prime of x as x approaches 1 from the right. So we're going to find both of these, and they will be equal to the slope of those tangent lines. And if we substitute 1 into our first one, we will get 15 times 1 squared, which is 15, minus 8 times 1, which is 8. And when we evaluate this, it'll be 7. And if we substitute 1 in for x in the second half of our derivative, we would get 1 over 1, which is 1. Notice these two values are not the same, so they're not equal. Therefore, it is not differentiable. So therefore, our answer here is B. f of x is continuous, but not differentiable at x equals 1.